so we talked quickly about this lab yesterday, okay, and kind of how it's going to work. Okay, the purpose, again, of this lab, or the problem that we're investigating, is basically whether Newton's second law applies in the real world or not, right? We're pretty sure it's going to work. It's worked every other time, so okay, I'm sure it will today as well. After all, it's called Newton's law and not Newton's hypothesis. Okay, so we're going to check this out by essentially changing the applied force in the system and then seeing what its effect on the acceleration of the system will be. All right, so we're changing the applied force in each trial, and we're measuring the acceleration of the system as a result. Things that we need to make sure of between trials: we need to make sure that the mass of the system does not change. Okay, because we know mass is another thing that can affect the acceleration of an object or system. So we need to make sure that that is always the same for all trials. So the way we're going to do that is we are going to set the mass of the system at a certain number, and then we're going to just maintain that number throughout the experiment by moving masses from one location in the system to another location in the system. All right, so what that'll mean for us is that we'll start out with 50 grams, okay, so a small mass, hung over the pulley. Okay, so hopefully you can see this. I'll move the chair out of the way so you can see it a little better. Okay, so I've got this set up here. If you can't see it, maybe stand up just so you can see what I'm doing here. All right, so I've got the cart tied to this string, which is strung over the pulley with 50 grams hanging over the pulley. That'll be trial one. The cart has a mass of 502 grams, and there are 400 grams worth of mass added to that cart. So we have 952 grams, or 0.952 kilograms, worth of mass in this system, and we are going to maintain that number on every trial. All right, so once I've got that set up and I've got the sensor on the end of the track here, and in fact, these sensors are designed to clip right onto the track, okay, they'll slide right on. I'll have it set up like this, and I'll get ready to release it. So you'll have one person who's doing the timing with the app, and another person who will have it set up like so. Okay, I'll try and keep my hands out of the way of the sensor as best I can, and then when the person operating the app tells me to, I will let the cart go. There will be another person at the end whose job it is to catch the cart. Stop the cart before it hits the pulley, please. Okay? All right, so Tyler's going to do that for me. It's not going to move very fast on this one, but by your last trial, when you've got lots of mass hanging over the pulley, this thing could jump over your thumbs. Okay, so you'll want to make sure you kind of put your hand down on it. Okay, so for this first trial, okay, I'll get the cue from whoever, and I'll let it go, and it'll accelerate towards the pulley. Okay, then it's done. The first one's easy. That's why we start out light and move towards heavy. Okay, now the key here, guys, is that we need to make sure that the string is taut when we start. Otherwise, the mass actually falls first and doesn't accelerate the cart until it jerks it. We want this to be as smooth as possible, so we want it set up that way. And we want to make sure that the string is just long enough so that when the mass hits the ground, we're essentially near the end of the track. Because once the mass hits the ground, it's no longer exerting any force on the cart, and the cart won't be accelerating anymore. All right, for that last 10 centimeters or whatever of the track, it'll be traveling at a constant velocity. So we're only going to want the part where it accelerates. Everybody follow on that? Okay, and then what we'll do on the next trial is we'll move 50 grams worth of mass off of the cart and over the pulley. Now, that's going to require a little bit of like permutations and combinations kind of a thing going for you here, because I've got two 200-gram masses on the cart. I can't just take one of them off and have added 50 grams over the pulley. So each group will need 2 sets of masses, okay? And then you'll have to do some fiddling around with how much mass you have on the cart and how much mass you have hanging over the pulley. Everybody follow me there? Okay, so you're moving 50 grams from the cart over the pulley. We got to make sure we keep the mass of the system the same throughout. Now, one other problem that you will encounter is that if you don't have some way to fasten these masses to the cart, they will fall off. Okay, especially in the latter trials when it's really going to accelerate quickly. So I will have some sticky tack, okay, that'll be over here. Just grab a couple of small pieces, put them on top of the cart, and push the masses down onto them so that the masses stay stuck to the cart during the experiment. Okay, so you're going to do 4 trials. You start out with 50 grams over the pulley. The second trial will be 100 grams over the pulley, 150, then 200. Don't go any higher than that. Okay, don't try and alter that formula. The acceleration will become too great for you to get any data. Right? It'll just happen so fast that your SparkView app will just miss it. You just won't have enough to do anything. Okay, so 50 grams at a time until you get to 200, then you're done. Everyone give her that. Okay, back in your desk, we'll talk about the hypothesis and stuff. Okay, so I've talked about the design. I've actually, in my little spiel there, told you what 3 of the 5 variables were. Okay, so you could watch the podcast if you missed that. For the hypothesis, okay, we need an if, and then statement that's a tentative answer to the problem. Okay, now the problem again we're investigating is essentially what's the relationship between force and acceleration. So I would say the if part of your hypothesis should probably tell me that. Maybe it should kind of say, what does Newton's second law say about the relationship between force and acceleration? All right, so the if part, okay, should talk about Newton's second law. Okay, what does it say about force and acceleration? The and part, as always, is going to give a brief description of the experiment, changing force, measuring acceleration, etc. Okay, the then part should tell me specifically what we're going to see as results. What's going to happen to the acceleration of the system as we increase the force? Okay. Okay. Try and use like good scientific wording, like directly proportional or inversely proportional or things like that when you're explaining stuff, especially in the if part. Okay, so you'll have a chart like this, okay, built already for you, I believe, in the lab report template. Okay, so you're just going to be filling things in. Okay, for trial 1, trial 2, trial 3. Okay, just fill those in. Remember, you're going to get the acceleration of your cart/system. Okay, from the slope of your velocity versus time graph. Now, you're going to only have one graph, but you're going to have 4 lines on it. So when you're building your data today in Google Sheets, you'll have one column that is time. Use the time from trial 1 for that because it'll be the longest, right? The other ones will all take less time because we'll have more force. So use the time from trial 1 and then put the velocity data for trial 1, next column velocity data for trial 2, next column velocity data for trial 3, and then 4. Okay, then you can highlight. I'll show you how to do that in a little bit after you guys have your data. I'll remind you of how to set up your graph. Okay, but that's how you'll do it. That's the only information you'll need in your Google Sheet to graph. Right? Then make sure you show the equation, because from the equation, okay, m is the slope, that's the acceleration. All right. Okay, for calculating net force, okay, we're going to take the mass of the system, which we already said is 952 grams, okay, and multiply that by the acceleration that we are getting in terms of our slope. Okay, the applied force is mass, the hanging mass, times 9.81. Theoretically, these two numbers should be the same theoretically. Not gonna be. Okay, they might be close, but they're not going to be exactly the same because, as we said, there are other factors involved, and what your job is in the analysis is to identify what are some of those other forces based on your data. Okay, was your net force bigger or smaller than the applied force? Based on that, you have to decide, did I have friction? Did I have F parallel? What other forces were involved? Identify and explain from your data. You might want to listen. Okay, so we'll have that chart, which we already talked about, okay, and then you'll have your graph. It should look something like this. We see ever increasing steeper lines as we go along, right? And then for your analysis and interpretation, okay, basically the first few are just talking about the graph and whatever calculations you need to fill in your data, okay? Number 4 and number 5 are the most important ones. What's the relationship between net force and acceleration? Sorry, I'm just going to bring it up for what it looks like on yours. Oh, and I don't have them on there. Okay, so the big ones in terms of marks, guys, are question number 4, question number 5, and question number 6. Okay, these are the main ones. Obviously, 1, 2, and 3 are just filling in your chart, doing some simple calculations. All right, but I'm looking for, well, in number 5, obviously a free body diagram. If you draw that by hand, just take a picture of it and insert the picture into the document. Right. For number 4, okay, I'm looking for more than like one word. Right, like if you write, inverse or exponential or linear or whatever you think it is, and that's all you write, that's not going to be good enough. Okay, I want an explanation to go with that. Number 6, that's the one where you really have to do all of the analysis. Okay, the net force and the applied force are not equal in value. Explain why this is the case using your knowledge of Newton's second law as well as your data. Okay, you've got to explain why your data says that is or isn't true. All right, conclusion, same as always, copy and paste your hypothesis, then using your data, explain why you can accept or reject it. Evaluation, 2 sources of error, ways to fix them. You don't have to do the class discussion. We'll talk about that when I mark the lab and hand it back to you. All right, are there any questions on what we're doing? Okay, there are only 4 tracks. Okay, so the groups are going to be kind of big today. So make sure you've got 4 tracks set up. Okay, get in a group. Okay, it doesn't really matter which group you're in, as long as you're in a group to get the data. Okay, make sure you send the data to everybody. 3 of the tracks are the short tracks. Then there's that ridiculous monster that at some point I'm going to hacksaw in half. Okay, but I haven't done it yet. So if you get the really, really long ramp, right, make sure that you're doing a good job of leveling. You're probably going to need to put it across 3 desks. Okay, in order to use it, but it works just like the others. It's just longer. Okay, you're actually not going to have your cart run any longer on the long track. You just have a much longer track to deal with. Everybody's distances are going to be about the same. Okay, because you're all going to be on a desk, and the masses can only fall from the desk to the floor. Okay, everybody follow? All right. So get together with people. Okay. Oh, by the way, you need the silver carts. Don't grab the black ones. Okay, you need the silver ones. The string is right here, okay, with some scissors. So just grab yourself scissors and string. When you're done the lab, leave the string tied to the cart. All right, that way my other classes don't have to cut more string and we can save some resources here. Okay, all right. Yeah, you can use that one. So once we have our data, here's what we need to do. Okay, we have our data here. I've isolated the time. I used the time from run 1, like I said to, because that's the longest of the times. And then I put in the velocity data. I have 5 runs here on the class data because that's the way we used to do it. Okay, but you guys would only have 4. So I'm going to highlight all of them. Then I'm going to insert chart. Okay, so we've done this before, right? So then Google Sheets tries to guess what kind of chart you want, and it's never right. Right? So we're going to go down here to scatter. That's what we want. And now I see, all right, I've got the data I'm looking for. Run 1 is the blue stuff. Run 2 is the red. Run 3 is the yellow. 4 is the green. 5 is the orange. Right? So I've got all of that on there. Okay, then I'm going to go to customize. And I'm going to go to chart axis and titles. The title it picked is crazy. I don't want it. Okay, and it's going to take me forever to delete it because it made it so long. Okay, so I'm just going to call it Newton Lab velocity time graph. Okay, and then I'm going to go to series. Okay, I'm going to apply this to all series. Okay, rather than just one. That's the nice time-saving feature of this new update. So I've just made the points smaller because they're awfully big. I want the trend line on there, right? For each one, I want it linear. Okay, and then I'm gonna put data labels on as well. Sorry, I got to go back to chart axis and titles for that. So chart axes here, horizontal axis, they've already got it in as time. Vertical axis, they don't have anything. So I'm going to put in velocity for that. And that's in meters per second. Okay, then I'll close that one up. Then I'm going to go to the legend. Okay, I want the legend. Actually, the legend's fine. I need to go to, series, and I want the where is it? Label. Down here where it says label, I want the equation for each run. Okay, like so. And then I'm good to go. So I've got the equation for each one of my trials, run 1, run 2, run 3. So now I have the slopes. Okay, now I can close that up and copy both the chart and the graph over, okay, into my, actually I don't need the chart, just the graph. Take the graph over into your lab and then you can start doing your analysis. Okay, so that's a reminder on how that part works.